Welcome to this video on Tukey's HSD test, a vital tool for identifying specific group differences in post-hoc analysis following an ANOVA. Developed by John Tukey, the Honest Significant Difference Test is a robust, single-step multiple comparison procedure. It is a universally utilized post-hoc analysis following a statistically significant one-way ANOVA. While ANOVA tells us a difference exists, Tukey's test precisely identifies which group means are significantly different by comparing all possible pairs. Running multiple standard t-tests inflates the type 1 error rate, leading to false positives. This is known as the multiple comparisons problem. Tukey's HSD solves this by adjusting the statistical threshold, ensuring the overall family-wise error rate remains strictly at your chosen alpha level. There are three key statistical assumptions for Tukey's HSD. First, independence. Data points within and between groups must be independent. Second, normality. Data within each group should follow a normal distribution. Third, equal variance, also known as homoscedasticity, meaning the variance across all groups is roughly equal. The HSD formula uses the studentized range statistic, mean square error, and sample size to output a critical distance. If the absolute difference between any two sample means exceeds this HSD value, those groups are statistically significantly different. Conducting the Tukey test starts with a significant one-way ANOVA. Next, calculate the absolute mean differences. Then, determine the critical value Q from standard tables. Use Q and the mean square error to compute the HSD threshold. Finally, compare your mean differences against the HSD threshold to find significant differences. In this clinical trial example, we compare a control group with 3 drug formulations. The ANOVA was significant, and the HSD threshold is calculated at 4.2. By comparing the absolute differences to 4.2, we determine which drug pairs show a significant difference. The chart visualizes the group means. According to the Tukey test, drug C is the only treatment that significantly differs from the control baseline, demonstrating distinct statistical superiority. Tukey's HSD is moderately conservative compared to other post-hoc tests. Fisher's LSD is least conservative, while Bonferroni correction is very conservative. Scheff's test is the most conservative and is used for complex, non-pairwise contrasts. Tukey's test offers a balanced approach, strictly controlling the family-wise error rate and preventing false positives. While slightly less statistically powerful than Fisher's LSD, its computational simplicity and reliability are key advantages. It assumes equal sample sizes for maximum accuracy. The key takeaway is Tukey's mathematical reliability. It allows researchers to compare many group combinations simultaneously, guaranteeing the overall probability of generating a type 1 error remains strictly capped at your defined significance level, such as the 5% FWER control.